Today's 204 experiment is on polymers, which is experiment number 40 in your book. We're going to make two types of polymers. One is a polystyrene, which is made from styrene. If you take a monomer like styrene and put a series of them together, you get polystyrene. So poly means many, mono means one. How we're going to do that, we're taking a chemical called dibenzoyl peroxide. We're heating it. It's going to break the chemical apart and form what they call a benzoyl oxyradical. The radical is going to combine with the monomer styrene to form polystyrene. This reaction takes at least 75 minutes. So once we start the reaction, we have to let it go for 75 minutes to completion. The second polymer that we're going to make is called nylon 610. This is actually how they refer to it as a copolymer. And a copolymer is made up of two different reacting materials. In this case, we're using sebacoyl chloride and 1,6-hexane diamine as the copolymers to make the nylon 610. The nylon 610 is the name of it is derived from the number of carbons in the different parts of the compound. So in the sebacoyl chloride, we have 6 carbons. In the hexane diamine, we have 8, 9, 10 carbons, so it becomes nylon 610. If we change the starting reactant, we can get a different type of nylon. You've probably heard more of nylon 6,6 instead of nylon 610, but we start with adipic acid instead of the sebacoyl chloride. So we're going to produce these two compounds. The formal report will be written. Answer questions 1 through 5 in the handout. And after we make the two compounds, we're going to test the solubility of each polymer in 3 solvents: acetone, methanol, and toluene. And the main consideration for testing the polymers in these solvents is we want to have roughly the same amount of each solvent and approximately the same amount of each polymer in each solvent to keep everything on a consistent basis. The first part of the experiment is to make polystyrene from styrene. We have pre-measured quantities of the material. Dibenzoyl peroxide is already measured into the test tube. And now we're going to add 1 milliliter of styrene that's pre-measured from a micro syringe. It dissolves pretty readily. And now we're going to put it into the sand bath for 75 minutes. Okay, we have the styrene dissolved in the with the benzoyl peroxide, and we're going to insert it into the hot sand bath for roughly 75 minutes. We want to cap it, but lightly, because it may build up a little bit of pressure. And just in case it blows the top off, it'll shoot it out that direction instead of toward us. So now we'll let it sit 75 minutes, and we'll just wait for the time to go by. So we'll start timing for 75 minutes. So we've waited the 75 minutes reaction time to make the polymer. We can remove it from the sand bath, and our polymer is already formed from styrene to polystyrene. We're going to put it in the ice bath and just let it cool for a while to solidify it a little bit more, and then we'll run our solubility tests in the 3 solvents. So now, with the preparation of the nylon 610, I have both solutions pre-measured and prepared. So the hexadiamine plus the sodium hydroxide is here, and the sebacoyl chloride and hexane is here. And now we're going to remove them and get ready for the mixing of the 2 components. Okay. Now we have the 2 solutions ready to mix, and we'll go to the next part of the experiment. Now we're going to mix the 2 monomers together. The sebacoyl chloride and the hexadiamine. There's a little bit of smokiness, but that's normal. Now you'll notice the 2 interface. We're going to let that settle out for a minute. We don't want to disturb it. It's pretty stable now, in equilibrium. And now we're going to extract our polymer from the interface. You'll notice the polymer that we pulled out from the interface. And now, as long as we have enough polymer, enough monomer of each type, we can generate a constant supply of polymer. Actually, in an industrial process, it's much more refined. They can control it much better. So this is laboratory nylon 6,6. And as you can see, as long as we're careful, we can just continue to make the polymer. If it breaks apart, we just restart it, pull out another segment, and restart it. And we can just keep going. As long as we have enough of each monomer. So we can terminate it at this point, just break it. If we want to start another roll, we can. Nylon 610. So we've reacted the styrene to produce polystyrene for 75 minutes, put it in an ice bath to cool it. That's the result of the produced polystyrene. Now we're going to remove it from the glass and take a segment out to do solubility. Okay, we're going to put a little piece of nylon 610 in each of the three solvents and observe it for a few minutes to check for solubility. These have been dried a little bit in the oven, and we'll just let it stay for a few minutes and see how it dissolves. Okay, we put a small segment of nylon 610 in each of the three solvents respectively, the acetone, methanol, and toluene. After a few minutes, we observed the particle that's there. It doesn't appear that the nylon 610 particle has dissolved at all in methanol or toluene, so we're going to call that insoluble. But the acetone the dissolution in acetone appears to be taking place, but very, very slowly. It's softening the nylon 610. We've inserted a piece of polystyrene in each of the three solvents, the acetone, methanol, and toluene. It appears that the solvent in the solvent toluene dissolved fully the particle of polystyrene. Methanol did not have any effect on the particle, so it remains insoluble. And acetone looks like it's in a somewhat softening, and it may be dissolving slightly. So that's the reported descriptions we're going to make. Our solubility descriptions, as we just noted, polystyrene was soluble in toluene, insoluble in methanol, and we can go partially soluble very slow. Slowly. Our nylon 610 solubilities are as follows. In toluene, it's insoluble. In methanol, insoluble. And in acetone, slow dissolving, slightly soluble.